Okay, this video is going to be a little bit longer just because this concept is a little bit more tricky, but I can assure you it's not essentially bad. We're here trying to find the points of intersection through elimination. In the previous video, we learned how to do substitution, where you're kind of basically saying like, oh, 2 is going to be 1 plus 1, and 2 is also 3 minus 1, so why not like smush them or combine them together in a way that you can just have this as the following. That's kind of the idea that we have with linear equations, mainly because in our linear equations, we have this y equals. Now, this y equals to mx plus b is what we call the slope-intercept form. However, when it comes to a linear equation, we kind of go beyond just having slope-intercept form. At some point, the slope-intercept form doesn't really help us, especially in the real world. To that, we have to lead us to the standard form. The standard form is still a linear equation, however, it's used in a different way. This is the general form of what standard form would be. It's ax plus by equals to c. Each of these numbers kind of represents something, but overall, it's supposed to just tell us more about the x and y intercepts. So this tells us about the x-intercepts, like where it's going to be. And technically, this is supposed to tell us where the y-intercept is supposed to be. The number is not supposed to be indicative of that, but it can help us out. So let's do an example problem where we have to find the point of intersection. Again, I'm going to shorten it as POI, but I'm going to find the point of intersection of the following. I'm going to do 2x plus y equals to 4, and in this case, I'm going to do negative 1x plus y, and I'm going to say this has to equal to negative 2. In this situation, we have to, again, probably do a visual, just because sometimes it helps us know where we're going. Here I have my graph, and luckily what I can do is that with these numbers, I can find out what my x and y values are. For example, 2x plus y equals to 4. If I cover up the y, that's just going to be 2x equals to 4. That means that its x is going to equal to 2 if I divide like this. So in this case, this is my x-intercepts. Meanwhile, while I erase the 2x plus y equals to 4, if I erase the 2x, that's y equals to 4. So I'm going to count that. 1, 2, 3, 4. And so now I have this new line that I can just create. And that's why it's called standard form, because I'm able to know technically the x and y intercepts. So 2x plus y equals to 4. Let's look at the other one, and the other one I'll go a little bit quicker. But you can see here that it's negative 1x plus y equals to 2. Again, if I cover, it's negative 2. If I cover the y, that's negative 1x equals to negative 2. In this case, x equals to 2 because of that. And then lastly, if I cover the y equals to negative 2. So these are my x and y intercepts. So I'm going to do this in yellow. We have it here at 2, 0, while the y-intercept is going to be at negative 2. So it looks something like this. Now, you already see where the point of intersection is. This is the POI. So we know the answer. We just need to figure out how to get there. To that, let's look at these two equations a little bit more carefully. 2x plus y is going to equal to 4. Well, negative 1x, I believe that then it's plus y equals to 2. Negative 2. In the previous substitution, we kind of got rid of one of the variables so that we can only leave it in terms of x. Well, here we have a problem. The problem is that x and y exist at the same time. So what in the world are we supposed to do? How do we get rid of x or y? To that, this leads us to this idea of elimination. Elimination is basically getting rid of x or y. But how do we do that? Well, think of it like this. If we have one and we have another one, how can I get rid of them? Well, if I want to get rid of this second one, I can just subtract. 1 minus 1, that gives me 0. So the same idea happens here. For step 1, I can get rid of it by either adding or subtracting the equations. So in this case, I notice that I have y, plus y and plus y in both equations. So I'm going to rewrite them again one more time. So in this case, I see that I have plus y and plus y. It helps us to figure out that, hey, we're trying to eliminate them. So one of the things that we can do is then maybe if we add, do you think y plus y would ultimately give us 0? No, it gives us 2y. It's like saying 1 plus 1. So we're not going to add. So we're going to instead subtract. We're going to either add or subtract. I'm not going to multiply or divide, and the reason why is because it doesn't really get rid of the variable. It just makes the numbers in front of the variable much worse or better. But in this case, we're just going to add or subtract. So in this case, we said subtract because adding didn't seem like it worked. I'm going to subtract like this, and I'm going to put a line right underneath. This is where the math happens. I see that I have 2x minus 1x, I have y minus y, and I have 4 minus negative 2. I'm going to combine all of these in a way. I notice here that I have two negatives, so I'm going to combine them to positives. So 2x plus 1x, 2 plus 1, 8, that gives me 3. I have y minus y, that gives me 0. And then lastly, I have 4 minus negative 2. It's going to give me 4 plus 2, which, hey, gives me 6. Using these different things, we can now combine them into the equation. 3x, this is technically 0, so I don't have to include it. And then I have to say that equals to 6. Hey, look, now I only have x. I don't even have to worry about other x's. This is a much different from substitution. How can I get rid of that 3 in front of the x? Well, luckily, this 3 is going to be multiplied with the x. So I have to do the opposite of multiplying, which is dividing. So I'm going to divide both sides by 3. Let's see what happens. I'm going to put a line right underneath to indicate that's equal. I notice I have the two 3's. The two 3's cancel out. And so I get x is equal to 6 divided by 3, which is 2. We just figured out x. So luckily, that was the second step. The second step was technically to solve for x. So solve for x slash y. It could be either or. If I try to eliminate y, I'm solving for x. If I eliminate x, I'm trying to solve for y. This is similar to now step 3. Step 3 in substitution asked us to say, hey, how are we going to find out the other one? Well, in the previous video, we said that we're going to use the other first two equations, and the same applies here. Now that I know that x equals to 2, we need to figure out how y can then equal, what y can equal to. I'm going to use the first one, 2x plus y equals to 4, and I'm going to plug in when x equals to 2. So I'm going to plug it in for x. If I write it, that's going to be 2. Instead of x, I can put a parentheses. And if I put parentheses, I'm going to put a 2 in the middle. I'm going to put plus y, and that's going to equal to 4. Let's do some multiplication. 2 times 2, that gives me 4. Plus y equals to 4. And then I see that I have a plus 4 right here. This is a positive 4. So maybe what I can do to get rid of it is that I can do subtraction. I'm going to subtract both sides by 4, just like this. Let's see what happens. 4 minus 4, that becomes 0. So y has to equal to, oh, we have 4 minus 4 again. That becomes 0. They cancel out, so we get 0. This leads us to our final step, where we can just write x comma y as our solution, equals to 2 comma 0. Which, hey, is something that we got up here, the point of intersection. So notice the differences between substitution and elimination. Substitution required us to do something called other x's, where there's an x on the left and an x on the right, but we ultimately combine the two together. This, however, for elimination is a little bit different, mainly because you had to either add or subtract between the two equations in order for you to ultimately get x or y to be a low. This is only part 1 of elimination, but there will be 2 more videos trying to explain other situations and other cases as well.